Hi, welcome. This is a video on factoring trinomials. This is at the proficient level. You really want to pay attention when you are told to factor completely. When that says completely, um, they're really saying that um, you want to watch to see if maybe it could be factored more than once. So factor you might factor out first the greatest common factor, and then you factor um, trinomials. Um, Difference of squares. I like writing like that, dos, because it's two terms, and then a trinomial. So if you go through and you factor it once, you might find that you could still use one of those factoring strategies. So watch for that. I'm going to take a times z. Recall that this is my ax squared, my squared term, plus my bx. So this time x is p, but it's the same, plus c. And then AC is 3 times negative 10. So that's 3 times negative 10, which is negative 30. And then our B term is 13. Once again, I'm going to use a different little table here. I'm going to say here's negative 30, multiply to negative 30, but add to 13. And I'm going to put 1, I'm going to start with 1 times 30. I know that one of them has to be negative for them to multiply to a negative number. But because 13 is positive, I'm going to put the positive on the larger absolute value, 30, and put the negative on the smaller one. So negative 1 times 30 is negative 30, but when I add those, negative 1 plus 30, I get 29, and that's not it. Negative 2 times 15. So again, I'm just putting the negative on the smaller absolute value. Negative 2 times 15 is negative 30. Negative 2 plus 15 is 13. So those are the numbers, and I don't have to keep looking. So negative 2 times 15 would give me negative 30, and negative 2 plus 15 is 13. So those are the numbers I'm looking for. Once again, I'm going to use a box. So I'm going to take my first term and my last term, 3p squared, 3p squared, put it there, and negative 10, put it there. So my first term in the first box, and my last term, negative 10, in my last box. And then I'm going to use my negative 2 and my 15. I'm going to put those in here to be the same as that plus 13p. So that's negative 2, but I have to put a p with it, negative 2p, and plus 15p. If you combine those, plus 15p minus 2p, you get 13p, which is that middle term. And then I factor out the greatest common factor for each row and each column. So the greatest thing that will go into both 3 and 15 is 3, and then they also both have a p, so 3p. And then negative 2p, negative 10. If your leading coefficient, so you think of negative 2p minus 10, negative 2p minus 10 as being kind of one binomial there. If your leading coefficient is negative, you want to factor out the negative. So not just 2, but negative 2. So I'm going to put negative 2 there. And then for this row, 3p squared minus 2p, 3 and 2 are both prime. They don't share anything, but they both have a p. So I'm going to take out that p. And then 15p and 10, I know they're both multiples of 5 because they both end in either a 5 or a 0. So I'm going to put plus 5 there. And then I'm just going to kind of double check. I know that 3p times p is 3p squared. Check. P times negative 2 is negative 2p. Check. Negative 2 times 5 is negative 10. Check. And 3p times 5 is 15p. Check. So the outside factors multiply to give us what's on the inside, the area, if you will, of that figure. And so Our factors then are 3p minus 2 times p plus 5, or vice versa. The order there doesn't matter. 3p minus 2, p plus 5. And that, we can see, is our answer.